Hello everyone, you're welcome to our channels once again. Today we shall be discussing on how to calculate aircraft stalling speed when performing a bank turn of a circle. Calculate the stalling speed in a level flight of an aircraft performing a bank turn of a circle in 50 seconds at 60 degrees. Let's pull out our parameters. Our aircraft performed the circle turn at 50 seconds at the bank angle of 60 degrees. Our gravity is given 9.81 meters per second squared. Now to find our load factor using the bank angle turn of the aircraft, we have cos phi equals 1 over n which is load factor. So therefore our n equals 1 over cos 60. From there we have our load factor n equals 2. Now we're told that the aircraft perform 360 full circle. So therefore our T180 equals pi v over g to square root of n squared minus 1. So under the condition of 360 full circle, our T360 will equals 2 times 180. That is times 2 of the 180, which gives us 2 multiplied by pi v over g into square root of n squared minus 1. Therefore we have our 50 equals 2 pi v over g over n squared minus 1 square root. That gives us 50 equals 2 multiplied by 3.14 multiplied by v, which gives us v equals 135.30 meters per second. Now that's our first velocity. Now to calculate the stalling speed velocity under the stalling condition, we have n, which is load factor, equals v over stalling speed all into square. From there we have our load factor, which is n, equals our first velocity, which is the previous velocity, which is 135.30 over stalling speed velocity, all into square. Therefore we have our stalling speed equals 135.30 over square root of the load factor. So our stalling speed, which is maximum stalling speed for the bank turn at 60 degrees, equals 95.67 meters per second. Thank you.